I'm Hamish, man. But a lot of people sometimes they call me bacteria, you know. So I don't want to waste no time. Let's get to the business. Know what I'm saying? If you face time here, there's a lot of new ones here. Okay. So before you get started, see right here, there's a red button, subscribe. Make sure you click the subscription button and have it get started. Okay, cool. So we have a exponential graph, but this graph is not given yet. They say y equal to kx means kx, but you know. This is how the smart student will do. Like, if I'm in your position, I'll say, oh, first and foremost, I got the point. X equal to 1 here. So these coordinates are known. X equal to 1 and the y equal to 4. Oh, there's another coordinate here. Which coordinate is this? X equal to 0 and y equal to 6. And then they say k of x equal to a negative x plus 2 plus b. So that's a k of x, means this is the k of x. So now what do they want? They say write down the equation that define k. But for you to get k, you need to know a and b. That's why they say here, oh, determine a and b, and hence you write down the equation define k. No, this is very easy. Whenever you have your equation and you have a known coordinate, take this coordinate, substitute in the equation, and then it's done. Let's go. So this is how we're gonna do. Okay, so I'm gonna say my equation is k of x. K of x equal to a negative x plus 2 plus b. So we have the first coordinate. Which coordinate? 1, 4. But 1 and 4, it lies on this equation. You see this equation? So you see, any coordinate lies on the graph. You can take that coordinate and substitute in equation. Yeah, so now we can take this lies on k of x. So we can insert the value. Insert the coordinate. Or we can just insert 1 and 4 into that one. Okay, so 4 is y, meaning this is y. K of x meaning y. You say k of x, or you say y is the same thing. You say that, even if they don't tell you. If somebody say f of x, g of x means y. So here, I'm going to put position of y, which is 4, equal to a, I don't know, a. Negative. What is my x? X equal to 1. So I can say a negative 1. Let me write. And then plus 2 plus b. Okay, negative 1 plus 2 equal to 1. So here I'm going to have a 4 equal to a power 1 bacteria power 1 equal to bacteria. You know what I'm saying? So this is going to be, because like a negative 1 plus 1 equal to 1 equal to a. So a plus b. So let's call this first equation. So now I'm going to take another coordinate which lies on this equation. Which coordinate? I'm going to use the same strategy for 0, 6, but also 0 and 6 also lies on k of x. So for that case, we can substitute these coordinates. Okay, y equal to 6. So here we're going to say 6. Okay, a is a. Negative x. What is x? X equal to 0. So negative 0, 0 plus 2. Plus 2 and then plus b. 0 plus 2 equal to 2. So 6 equal to a square plus b. Oh, so 6 equal to a square plus b. Let's call this one second equation. So I can solve first and second simultaneously. You know what I'm saying? So what I'm going to do, I'm going to make a the subject, and then, excuse me, b, and then it's going to come in here. So I'm going to say, check this one. You see, because if I make b, and then I'm done. So I'm going to say, but, excuse me, but, let me make b the subject here so I can solve simultaneous. So say my b equal to, a is going to come here, means b equal to 4 minus a. 4 minus a. So this into that means, let's take this equation here. You say, but we know b equal to 4 minus a. So then it's going to come in here. Okay? So we're going to say now it's going to become 6 equal a squared plus, what the position of b? B, value of b equal to 4 minus a. So 4 minus a. And you see now you have a quadratic equation. So now let's rearrange good and they solve. So everything is going to go to the right. Is equal to a squared plus, let me start with the negative a because it's quadratic already. Okay. Okay, let's go step by step. 4 and then I'll show you. Okay. Oh, I could have said this is equal to a squared plus 4 minus a. So I'm going to say a squared minus a. I believe now it makes a lot of sense. Minus a and the plus 4 and these 6 go over. So 4 minus 6 equal to negative 2. Negative 2. So now I can factorize or I can just solve now. Okay, let's go factorize. Okay, how we get a squared? A squared, this must be a, must be. How we get 2? 2, 1 must be 2, must be 1. But for the negative here, means the big, okay, excuse me. Okay, for the negative, one must be negative, one must be positive. But I look at the middle number. The middle number is negative, means the bigger number must be negative, and here it's going to be positive. Let's go. A and a squared. We want to prove, right? A and a squared, a and this is a. Yes, I got it. Okay, so this equal to 0. Either a minus 2 equal to 0 or a plus 1 equal to 0. So a equal to or a equal to negative 1. Now, let's see which is going to make a lot of sense. So we have a equal to 2 and a equal to negative 1. You know what I'm saying? Okay, so this is a here. Okay? This is not true. You know why? Because these exponentials like this. When it's like this, must be positive. You know what I'm saying? But we're going to check. Okay? We're going to check. We're going to prove it's true. It's not true. So now, for now, we need to pick 1. We can take 2. Let's see. We say a equal to that. Okay. If I say, for example, just normal exponential. Let's say normal exponential. Okay. Let's say somebody give you y equal to negative 3x. We want to see the nature of this equation. Or a equal to 2x. So we want to see which of these two is going to look like this. Now let's go. When let's say x equal to 0, what's going to happen? It's going to be equal to 1. Oh, when x equal to 0, y equal to 1 means somewhere here. Okay, x equal to 1. When x equal to 1, it's going to be negative. When x equal to 1, okay, calculate this a minute. Negative 3. Okay, negative 2. Positive 2, excuse me. Oh, negative 9. 1 equal to 1, negative 9. Negative 1 equal to 1, negative 9, you see? So, okay, cool. Okay. When equal to 2, 3, let's say. So when this equal to negative, this graphic might go like this. It goes down, you know what I'm saying? Stuff like that. But if it's positive, means it's going to be based on a positive. You know what I'm saying? You can't even try to put the bar like when x equal to 0, it's going to be 1. When x equal to 1, like there's no way this graph is going to go under, below, means it's going to be like this. This is like a rough sketch. Even try to draw like slowly, take a calculator, plug the value. Okay, when x equal to 1, it's going to be 2. X equal to 2 is going to be, even if you put negative, say 2 power negative 6, look. It's still positive, like it's going to come like this. But if it's negative, it's going to go under. Let me just make sure for negative also. Yes. So when it's negative, this graph might go under. So this is for the positive, not this. So this is not the answer. So for that case, you must say this is not. You know what I'm saying? That's not. So, okay, so for that case, we're going to be doing only a equal to 2. A equal to 2. So for that one, take your calculator, try to plug it in and see. You know what I'm saying? Now, so we have an a. If I have my a equal to 2, I'm going to come and substitute here to get b. So say then b equal to 4 minus a, 4 minus a plus 4 minus 2 equal to 2. Also b equal to 2. So for that case, I have a and b. So then y, which is k of x, equal to a. What is my a? I know. A equal to 2. Okay. Negative x plus 2 plus b. What is my b? B equal to 2. You know what I'm saying? So we got it. So after get them, what do they want? They say, what is the equation? So we have equation. Let me write here the equation. So this equation is 2. Let me write here because I want to make some space. K of x y, or k of x equal to 2 negative x plus 2 and then plus 2. See, this is horizontal asymptote. This represents horizontal asymptote where the graph is going to cut this. See, this is called horizontal asymptote at 2. Horizontal asymptote. Why? So this is a horizontal asymptote whereby the graph will never touch with horizontal asymptote. But it's not part of the equation. This is what I'm looking for. So I'm going to write here and make a space, okay? And then we do our second part, which is the inverse of a function. Okay, so for inverse of function here, they didn't say inverse, but it is inverse. You know what I'm saying? Okay, so now look. If I had to find y equal to x, what is y equal to x? Look, if I have a graph like this is the line of y equal to x. So if I have a point here, let's say this point is 2 and 4. If I had to count y equal to x, means it's going to come at this position. So it's going to switch. If this x equal to 2, right? So it's going to become at y, means it's going to become at y. It's like they're going to switch one another. You know what I'm saying? And even the sign is going to change because everything is going to come in. So for that case, means whatever is going to come in is going to switch. X is going to become y, y is going to become x. So now, let's say you have a graph, like that graph here. Excuse me, so y equal to x means this graph might be there. It's a possible graph. So in other words, you replace y with x, but when you replace y and x, we call it inverse of a function. So even though they did not say inverse, but I will know it's inverse of a function when you replace y equal to x. So what is the equation of the graph that obtained by reflecting the graph of k around the y equal to x? So what we're going to do, see that's the equation now. So we say reflecting y equal to x. Sometimes we can call inverse of a function. Inverse of a function. Because inverse is when you reflect y equal to x. So we given, no it's not given, we have calculated our equation. Y equal to x plus 2 is negative, right? Negative, yes. Even here must be negative, sure. Okay, and then plus 2. So we say for inverse or y equal to x, what that means this is y is going to become x, and this is 2, and this is x is going to become what? Y, and then plus 2. Okay, so what we're going to do, we have to make the y the subject. Then we'll make y the subject, that's the end of the business. But mathematical, this time we say we have x equal to, I can say 2 power negative y, and the same 2 power 2 is acceptable mathematical, okay, from the exponential rule. These are rules of exponential, accepting it, okay. 2 power 2 equals 4, so x, 2 power 2 equals 4, so this is going to be 4, 2 power negative y plus 2. So our intention, we want to make y the subjects. You know what I'm saying? So after that, this same is say, from that is proper rule, say x equal to 4. This is going to come under, because you reciprocate, it's going to become 2 power y. You know, you reciprocate, it's going to become 2 power y, and then plus 2. So we want to make 2y the subjects. How do we want to make 2y the subjects here? This is tricky a little bit. Know what I'm saying? Easy. Take these 2 over. So let me do here. So these 2 come over. So this is going to become x minus 2 minus 2. And this equal to 4 over 2y. You know what I'm saying? It's a lot of ways you can do. Either you can cross or you can flip. But let me cross. There's a lot of ways, okay? What I'm going to do is say this is over 1 because we want to make the y subject. Cross multiplication. 2y times there, say 2y. And then x minus 2 equal to 1 times 4 equal to 4. We want to make y the subjects alone. So we divide by x minus 2, x minus 2. So divide by x minus 2 here. Look, divide by x minus 2. Divide by x minus 2. So our 2y equal to 4 over x minus 2. So how you want to make y the subjects? You must apply logarithm there. Either you apply logarithm or log. Did I mention it? No, logarithm. Because if you change something from exponential, most of the time is logarithm function. From exponential to logarithm. So I want to apply log throughout. So I'm going to apply here log on the left, log on the right. So say log 2 power y and then log of 4. I can even minus if I want, because whenever it's division I can minus. But for now let me just leave it how it is. 2. And then what happens? This is the power, remember. So I'm going to go to the back. So it's going to become y ln of 2, because this can come to the back. Okay? Equal to log my apologies. Let me say log here. Okay, log 4x minus 2. So for that case, now I want to make y the subject. Divide by log 2, divide by log 2 throughout. So yeah, I think I can finish here. You know what I'm saying? So let's finish here. So this is going to become y equal to log 4. I can just say, okay, cool, log 4. Do this. Log 4 over x minus 2, and then divide log 2. I'm saying divide by log 2 because you have to divide by log 2, divide by log 2, divide by log 2. So we just simplify, you know what I'm saying? Because this is the equation we're looking for. So our equation we're looking for equal, can I simplify there? No. No, there's no such a rule. You cannot. You start like that. But somebody might say, man, didn't you say like if you have a division we can minus? This one on top, yes you could. The one to say log 4 minus log x minus 2, and then all of this over log of 2. Maybe that could be the largest number. You can't go farther than that. You know what I'm saying? You cannot. So that will be my final, but I'll rather stick to this. But no. I can say something more there. That rather than writing like this, I could have said like this. Look. I could rather say, we have a rule in logarithm. It always say this is not true, right? If somebody give log of a over log of b. You see, this is not like this. Two different things. We know already this is same as say log of a minus log of b. But this is, can you see the line? This is over. So this mathematical same as say log of a, and then take this b, put it in the base here. Acceptable. So this is like, look, this is like a, look. All this is like an A and this is like a B. So I'm going to say y equal to log, and then I can say this is 4, and then x minus 2, and then this 2 is going to come here as a base. And this could be the most simplified. Yes. But then I can continue a little further if I want. I could say, oh, okay. But if it's like this, you know, I could say it's like A over B. Can you see? A over B. A over B. And then same base, which is 2. So this, let me say, y equal to log 4 of the top minus log of x minus 2. But this is base 2, and this also, both are base 2. Both are base 2. So this minus this. You know why you minus? Only when the bracket is single bracket, not like this. This you don't minus. You know what I'm saying? Pay attention to that. So this one I can simplify, because what is 4 is 2 squares. Say y equal to log of 2 square under base 2. But these 2 can go back. You know what I'm saying? If these 2 can go back, it means it's going to be like this. 2 log 2 over 2, and then minus. Here I don't do anything. I don't even want a problem with this, man. Okay. What is log 2 over 2? Equal to 1. Same log, same base equal to 1. Somebody say log of m under base m equal to 1. So this is going to be 2 times 1 equal to 2. So y equal to 2 minus log of x minus 2 under base 2. Oh, we cut it, you write everything. You know what I'm saying? Yay! Oh, 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 yeah, yeah. Oh, whoa, 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 da, 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 da. So if it's time, man, you know, subscribe and share to a lot of people. My peace.